To a new video in my channel Pre-Med Max. Today we're gonna be looking at some organic reactions. But before, let me introduce you to some concepts. Nucleophile and electrophile. Okay, phile comes from love, so nucleophile and electrophile. The way that I remember nucleophiles is the bases are nucleophiles. I just remember like something basic, kind of space in its nucleus. That's the way I remember. But the way you can remember is that in the nucleus there is protons that are positively charged, and nucleophiles they're proton loving. And you can remember the basic substances. Nucleophiles most of the time are basic substances. There's like a few exceptions, but right now, nucleophiles are going to be basic substances. You can remember that basic substances they want to get rid of their negative charge, right? So that's why they're looking for protons, which are found in the nucleus, and that's where the name comes from, nucleophiles. The way I remember is when someone's basic is in its nucleus, he doesn't want to learn more. So electrophiles, most of the time, they're acids, right? And they're positively charged. The way the instruction will tell you to remember this, it will be like, oh, it's positively charged, electrons are negatively charged, so it wants to get rid of its positively charged, and it's looking for electrons. That's why it's an electrophile, like what, like electron loving. That's why you have like hydrophilic substances. Like I just had to make sure I was correct. Yeah. So hydrophilic substances is like the water loving. It doesn't relate. The water loving doesn't relate right now to this topic. But I just remember in Bio 1 and other classes in biology, we learn about hydrophilic substances. So now we have electrophiles. You know, or like a bibliophile. It loves to read. An example of it. Some examples of basic substances is the OH. Some example of acids, as we remember in our previous chemistry classes, it will be the H3O plus and the H plus. So in other classes, the H plus it used to serve to say that it was this one, but you can in this class the H plus doesn't mean that. Right, you can have the H3O plus and the H plus. Reaction, you are gonna have you have to identify the electrophile and the nucleophile, so you know how the reaction works, right? So you have to identify the nucleophile and the electrophile. So we know this one is OH, negative OH. We already know it from other classes. We should have a knowledge about this substance before. And after that, so we know this one's going to be basic because we know OH is basic. After that, we identify our electrophile.
Jesus, so where are we, Jesus? Where are we? Why camera quality is like this? Okay, so the camera quality is like this because I'm recording in selfie mode. And so while I was editing the video, I already recorded this video, like it's my third time recording the video. I realized first time I didn't do the audio test, so the microphone wasn't connected. So I usually do something like, this is an audio test, and I'll listen to it. But I didn't do it because I was in a hurry. And I was like, oh. So after that, I remade it, but looking that way. So I go to class, I start editing the video, and I'm like, no, the video it's not recorded. That's why I already have something in this board. So, because whenever I didn't make the audio test, like the audio sound like shit, I'm in the library, so I hope if you cannot hear me, just like pump up the volume a little bit more, because I don't want to be like crazy. Because somebody in my college library is about to call me and be like, "Yeah, Jesus, be quiet." Okay, so we already talked about the little spoiler. Let me see if I have something to delete. It's gonna be my face, guys. I'm ghetto. Okay. So, okay, after my little spoiler. So we talk about the electron pushing hours, right? So in this one, the OH, the OH is a negative charge element, so it's a base, and it's gonna react. So something that really happens frequently, it's you remember in Chem 2 you had like your acid base reactions. This is not acid base reaction, but like you had them and it's like it was like, oh, acid base, it becomes water. So water for organic reactions, it really happens a lot. So whenever you see like a reaction like a negative OH, expect water be one of the products. Like hydrolysis is a really common product, right? So if water can happen, most of the time it will. There's exceptions, but it's just like, oh, there's an OH, or there's an H. I wonder where it might happen, right? So the electron push hours are already in the problem they were giving. We're just asked to analyze what would the products be, right? So the electron pushing hours tell us what's going to happen in this. We notice that from the electron pushing hours, we always start from the nucleophile to the electrophile. So it's telling us this is showing one of the electrons to the H, which is gonna create a water. So now you have two H's bonded to an oxygen, and I hope you know how water looks like. This is how water looks like. So we have H2O, and now we go to the next one. It's telling us that this bond's breaking and the electron is gonna push here. So it's telling us that oxygen has a double bond. So now we think back to this molecule, right? And it's like, okay, but have carbon only has four valence four valence electrons. It's I'm not sure, right? So carbon can only make four bonds. If a carbon has three bonds, it's probably considered a carbon cation or a carbon anion. But like usually carbon makes four bonds, three bonds, and I'm not aware if carbon makes five bonds, but I don't think it does. Because carbon cations has three bonds, carbon anions is three bonds. So as long as I'm aware, I'm just a college student, carbon does not make five bonds. I'll put in the comments to see if carbon ever makes five bonds, but I don't think so. So carbon only makes four bonds, right? So what this electron hour is telling us that this bond is gonna break. So carbon doesn't have to have five bonds, and it's telling us that we wanna have an oxygen, an ion. An ion, it means we already talked about this in videos before, but if this is your first time ever looking at it, it means like a negatively charged. So we're gonna have an oxygen. It's negatively charged because it has more electrons on it. So we're gonna have an oxygen that's negatively charged. Okay, guys. I have 18 minutes before my organic chemistry one class. Yes, I'm taking OChem 1, 2 for the ones who's a newbie person, and just liking this. So, but I think I have okay grasp in the material. So yeah, let's go. Let's see if I can finish this small part here. So we have an OH again. Well, it's backwards, but it doesn't matter. We have a negative OH and we have a hydrogen. So we know if they are reacting, we want to have a water, right? We want to have a water. So after that, we want to have these electrons here, and they're saying these electrons are going to break, and they want to come here, and this is going to form a double bond. So it's telling us that this carbon, it's making a double bond, right? And after that, what's this telling us? It's telling us that this oxygen, because this carbon now has, let's put it right here, because this carbon now has five bonds. So what's this hour telling us? It's telling us that a bond's breaking, and we want to have an anion. So that's gonna be our products for this one. Our products is telling us that like, the bond's breaking. That's why the arrow starts for the bond. It's telling us the electrons are breaking. So now we're gonna have a negatively charged oxygen. This one is telling us that they're sharing electrons. These purple electrons are sharing. That's how the wire form, right? And this is telling us that it's making a double bond. That's what the electron hours mean.
We are back. Okay, after a haircut and a day of classes, I'm back to finish the video. Y'all wanna see my setup of how I make the videos? Y'all want to be let in the Easter egg? So I have the computer right here, I have a chair, and I have a table, so y'all can see me. Okay, let's cut to the chase. We have this molecule right here. Let's analyze the molecule before even looking at the errors. Before even looking at the errors, let's analyze the molecule. So we have a water molecule right here. We have a carbon. We have a positive oxygen. What does this mean? It means it's making too many bonds, right? Oxygen doesn't like that. It's missing an electron. That's why it's positive, right? And we have a hydrogen. So what are our bond arrows telling us it's happening? Our bond arrows is telling you the wire is donating its electrons to carbon, and carbon is binding to those electrons that are being donated. So it looks something like that. And after okay guys, there's already stuff on the board. Let's not worry about it. I can delete it. Okay. If this is stuff, if the stuff in the board like it interferes with me expressing what I had to express, teaching what I had to teach, let me know so I can delete it. But if you don't really mind, like whenever I give an explanation, and if you don't really mind, there's stuff, but if you prefer me to walk step by step, be like, give in the comments like, no, Jesus, I prefer if you walk me step by step. Be like, okay. So as I was saying, this one donates its electrons, and now this, because it donated its electrons, it made a bond with carbon, right? We're not in this step yet. So it made a bond with carbon, and now because it made a bond with carbon, it has a positive charge because it had to donate its electrons in order to be able to make that bond with carbon. Because carbon is already using all its valence electrons, right? So it had to donate that in order to make that bond with carbon. And carbon at this moment, it has 5 bonds. Oh, talking about the 5 bond thing, I googled it up. Carbons can have 5 bonds, but it's really unstable, and that substance would probably react with another substance right away, or it will do a chemical process, and it's called Texas carbon. Anyways, carbon has 5 bonds in this specific moment. So you have a positive charge because it only has 1 electron pair. And if you remember, electrons are negatively charged, as we mentioned earlier. So this one is missing some of its electronegativity. So it's a positive charge, right? And this arrow is telling us the bond is breaking and it's donating the electrons to the oxygen. That's why the oxygen now becomes a normal oxygen, a normal charge oxygen. It is a neutral charge, it doesn't have a positive or negative charge because it just doesn't. Like, it has all its valence electron and everything is in the right place. So this structure is represented like this in the bond. Let's remember that there is like this form of representing carbons. I think it's called the skeletal formula, maybe the structural formula. I don't remember the exact name, guys. But this is a way of representing carbons, and this is represented as the central carbon. These are our 2 methyl groups, and this is our positive charge water. and this is our alcohol group. La última y nos vamos. Last one and we leave. And you are dismissed. That's funny. Okay, so we have our, I forgot to add the charges, I'm so sorry. We have our nucleophile, right? No, yeah, our nucleophile. We have our nucleophile because negative is basic. Negative people, they are so basic. I'm positive. Okay. Okay, so negative people are basic, right? So what's this telling us? It's telling us that it's gonna share its electron over here. And because the bond's breaking, it's meaning that this is gonna share both of its electrons, and it has a negative charge that this oxygen wants to get rid of. So we can assume this reaction is gonna happen. You can assume this is gonna be one of the products because the oxygen wants to be like this. So oxygen is more than happy to donate its electrons to hydrogen and be like, hey, don't bring any electrons, boy. Like, you're fine. Let's just chill. So we can really assume that's going to be one of the products. And the arrows are telling us so. This is what the video is about. The arrows are telling us this is what's happening. Also, the arrows are telling us this bond is breaking and it's coming to this double bond. These electrons right here are going to become part of this structure. Right? So it's telling us that in this structure, there is going to be a double bond now and there. That's what this arrow is telling us. It's telling us that now there's going to be a double bond. Let's remember that this is to signify where the bonds are. If the bonds are like this, it means they're looking towards you. If the bonds are like this, it means they're looking kind of away from you. So these are still bonds, and it means the bond is breaking and it's forming a double bond. So we have our metal group looking towards us, and we have a bromine looking towards us, and we have other metal looking away from us. And after that, it's telling us that this bromine is gonna detach itself. So this carbon right here, so let's remember this little dot is a carbon, and now this carbon, like as we look at it, it has 5 bonds. It has 1, 2, 3, 4, 5. So it's gonna detach itself to don't give that burden to the carbon. It's gonna detach itself, and we're gonna get bromine anion, negatively charged. It's gonna detach itself, and this is gonna be our product. We're gonna have 2 metals looking towards us. We're gonna have this group over here, and a bromine anion. In these problems, we haven't been asked to like imagine or deduce what the problems are going to be. We're giving electron arrows, which is really helpful. In for future problems, we will not be giving these electron arrows. Well, guys, it was a longish video. I hope y'all enjoy it. I hope y'all learn. I really like all the support that I've been getting from you. Views has gone up. I got in 2 really nice comments that I want to shout them out. I cannot afford to buy a camera yet, a professional camera, but someday I will have 500 subscribers. Someday I will start monetizing from the channel, and I will afford a nice camera, and we will look at this as like, oh, you remember? So give a like, share, subscribe, and thank you so much for all your support. This is Primet Max. Goodbye.